Hello everyone! Before we talk about these properties of the set of integers, magtanong muna tayo, ano ba ang integers? Ang integers ay may iba't ibang uri o klase. Ito ay ang positive integers, zero, at negative integers. Positive integers are widely known as counting numbers or natural numbers. Ang whole numbers naman ay kombinasyon ng zero at counting numbers. Another question is, do we have to learn these properties? The answer is yes. If you understand these properties, then you're gonna have the magical ability to successfully solve problems in algebra or even higher mathematics lessons. This is Alberto Filisilda, mathematics teacher of Old Damulog National High School. Let's begin with closure property. Assuming that A, B, and C represent any positive integers. Closure property for addition states that the sum of any two positive integers A and B is equal to positive integer C. Let's study the example. Add 35 and 32. Obviously, the result is 77. Since all the numbers are integers, therefore we can say that it is closed operation. Let us verify closure property for subtraction. So let's study the situation. 10 minus 25. The answer is negative 15. Take note guys, 10 and 25 are elements of positive integers. But the answer is not positive number. So therefore, this is not applicable for subtraction. Closure property for multiplication states that if two positive integers a and b multiply together, then the result is positive integer c. Example, 25 multiplied by 10. Since the answer is 250 is a positive integer, hence we can say that closure property for multiplication is closed operation. Closure property for division. Let us verify this one by citing example. 15 divided by 4, the answer is 3.75. Since the answer is not a positive integer, therefore we can say that closure property for division is not applicable. In summary, closure property works only for addition and multiplication. This property states that if we add or multiply any positive integers, their sum and product are positive integers. The second property is commutative property. Again, let us assume that A, B, and C represent any positive integers. Commutative property for addition, defined as the order in which you add any two integers, does not affect the sum. Example, if we add 12 and 8 using the left-hand solution, 12 plus 8 is 20. While using the right-hand solution, 8 plus 12 is 20. Notice that the answers in left-hand side and right-hand side are equal. Thus, we can say it is closed operation. Another example, if we ask to simplify these three numbers, 12, 80, and 13, we can rearrange the order of the numbers. We can add smaller numbers such as 12 and 13. Applying the PEMDAS rule, so 12 plus 13 is 25, bring down 80. So 25 plus 80, the result is 105. Example number 3, simplifying 9 plus x plus 16. We can rearrange the order of numbers. 9 is now on the second term of the expression. Afterwards, we can add the last two terms of the expressions. which is 9 and 16. 9 plus 16 is 25. Moreover, we cannot combine x plus 25 since they are different terms. So the final answer is x plus 25 or 25 plus x. Example, we asked to find the difference of 15 and 8. Using the left-hand solution, 15 minus 8 is 7, while using the right-hand solution, 8 minus 15 is equal to negative 7. So, as you can see here, the left-hand side is not equal to the right-hand side. So, therefore, a minus b is not equal to b minus a. So, we can say that this is not closed operation. Commutative property for multiplication states that the order in which you multiply any two integers does not affect the product. Consider the example here, 5 times 8. Since the result of the left-hand side is equal to the result of the right-hand side, therefore we can say that it is closed operation. Further example, simplify 5 times 9 times 2. Using the concept of the property, we can rearrange the order. 2 is placed in the second term and 9 is placed in the last term. We can apply PEMDAS, solving the first expression inside the symbols, which is the brackets. So 5 times 2 is 10, then 10 times 9 is 90. Another example is 9 times x times 2. So here we just place 2 on the second factor of the expression. So 8 times 2, you have 16, then times x equals 16x. Let us verify this property that the order in which you divide any two integers does not affect the quotient. Since the left-hand side is not equal to the right-hand side, thus we can say it is not closed operation. Commutative property is only possible on addition and multiplication. No matter you have interchanged the addends or the factors, still their sum and product are just the same. The third property is associative property. So let that a, b, and c are all elements of integers. Associative property for addition states that adding three integers, the grouping of the numbers does not affect the sum. Let us verify the property by adding 2, 3, and 4. First solution, using the left-hand side, we group the last two terms of the quantity. So applying PEMDAS, add the 3 and 4, and that is 7. Then 2 plus 7 equals 9. While on the second solution, using the right-hand side, we group the first two terms, 2 and 3. Then we add, that is 5. Bring down 4. Then the result is 9. Since the left-hand side is equal to the right-hand side, then we can say it is closed operation. Second example, add 17, 83, and 24. So we group the first two terms. Then that is 100. Bring down 24. The result is 124. Example number 3, add y, 23 and 72. So using the properties, we group the last two terms. So 23 plus 72, that is 95. Then add with the first term, that is y. So our answer is y plus 95. Let us verify associative property for subtraction. It states that when you subtract any three positive integers, the difference is also the same. Let's try the example 5 minus 6 minus 7 using the left-hand side solution, so we arrive with the value 6. On the right-hand side solution, we arrive with the value which is negative 8. Since the left-hand side is not equal to the right-hand side, therefore we can say that a minus quantity b minus c is not equal to quantity the difference of a and b minus c. Associative property for multiplication states that when you multiply any three integers, the grouping of the numbers does not affect the product. Consider the example here 3 times 5 times 7. So using the property, we multiply the last two factors, we get 35, then multiply it with the first factor 3, then we arrive with the value 105. Using the right hand solution, we multiply the first factor 3 and 5, that is 15, then multiply it to the last factor 7, then we arrive with 105. Since the left hand side is equal to the right hand side, therefore we can say that it is closed operation. Further examples on associative property for multiplication: simplify 8 times 11 times 3. So we group the first two factors 8 and 11. We multiply it together, so that is 88 multiplied by 3. So we come up with our answer 264. The third example is simplify 6 times r times 7. So we group the last two factors, r and 7. We enclose it with bracket, so we multiply together. So we have 7r, then bring down the first factor, which is 6. Then 6 times 7r, we arrive with our answer 42r. Let's verify associative property for division. When dividing any three integers, the grouping of the numbers does not affect the quotient. So let's take a look with example. Divide 20 by 4 by 2. So using the left hand side solution, so we divide the last two numbers. 4 divided by 2, so we have 2. Then 20 divided by 2, 10. So that is the solution for the left hand quantity. On the right hand side, we divide the first two numbers. 20 divided by 4, 5. Then we divide it with the last number 2. So we arrive with 2.5. Since their answers are not equal, therefore we can say that it is not closed operation. Associative property works only for addition and multiplication. When adding or multiplying any three integers, the grouping of numbers does not affect the sum and the product. The fourth property is distributive property. Let A, B, and C are elements of integers. Distributive property of multiplication over addition. This property can be symbolically written as A times quantity B plus C is just equal to the product of AB plus AC. Example number 1. Distribute 2 times quantity 3 plus 5 using the left hand side solution. So applying PEMDAS, we solve first the expression inside the symbol. So 3 plus 5, 8. 8 times 2, 16. So that is the answer for the left hand side. On the right hand side, we just simply apply the distribution of factors. So we have 2 times 3, 6, 2 times 5, 10. Then we sum them up, so we arrive with 16. So as we can see, the left hand side is equal to the right hand side. So therefore, we can say it is closed operation. Further example is distribute 4 times quantity 3 plus 5. So using distributive property, so we just multiply 4 times 30, then plus 4 times 5. Then the product of 4 and 30 is 120. The product of 4 and 5 is 20. So we add together the numbers, so we come up with our answer 140. Let us verify distributive property of multiplication over subtraction. So, example number 1, distribute 7 times quantity 5 minus 3. Using the left-hand side solution, we first operate the PEMDAS. So, 5 minus 3, 2. 2 times 7, 14. On the right-hand side, we just simply multiply 7 times 5 and 7 times 3. Then we get the difference of the product of the two factors. So 35 minus 21, we have 14. Since the left-hand side solution is equal to the right-hand side solution, therefore it is applicable for subtraction. Another example for distributive property of multiplication over addition: distribute 7 times quantity 25 minus 6. So we just simply multiply 7 to 25, then simply copy the operation, subtraction, then 7 times 6 we have here. Then we just get the product of 7 and 25, that is 175. The product of 7 and 6 is 42. So the answer is 123. To remember this property, simply multiply a to the inner terms of the quantity b and c, and then simply copy the sign of the operation inside the parentheses. Identity property for addition states that there exists a unique integer 0 such that for every integer a. It means that when a number is added to 0, the result is the number itself. Example number 1, add 23 plus 0. The result is 23. Example number 2, find y, where y plus 0 equals 48. Applying the property, then we have y equals 48. Identity property for multiplication states that there exists a unique integer 1 such that for every integer a. It means that when a number is multiplied by 1, the result is the number itself. So example number 1, multiply 25 times 1, the answer is 25. Example number 2, find z, where the equation is 1z equals 94. So 1 times z, that is z, and z is equal to 94. Inverse property for addition states that there exists a unique integer negative a for every integer a such that a plus negative a is equal to 0. It means that when we add opposite numbers, the result is 0. Example here, simplify 91 plus negative 91. So when we add these numbers, since they are opposites, then we have the answer 0. Example number 2, find y, where y plus 12 equals 60. So in order to eliminate the positive number on the left-hand side equation, which is positive 12, so we're gonna add negative 12, its opposite of positive 12. So both sides of the equation, we add negative 12. So positive 12 and negative 12, when we add together, the result is 0. So this is how we can apply additive inverse. So y plus 0 equals y, then we simplify the numbers on the right hand side of the equation, so we get 48. So the value of y is 48. And for inverse property for multiplication states that there exists a unique integer 1 over a for every non-zero a such that a times its reciprocal, which is 1 over a, is just equal to 1. So when we multiply a number and its reciprocal is just equal to 1. So example here, simplify 28 times 1 over 28. So when we multiply this number, since they are reciprocal, the numerator becomes the numerator of the second number, and the denominator of the first number becomes the numerator of the second number. So this is the concept of reciprocal. So we interchange the value of the numerator and the denominator. So we give the result, which is 1. Example number 2, find z, where 2/3 z is equal to 8. So to find the value of z, we need to find out the reciprocal of 2/3, and that is 3/2. We multiply 3/2 both sides of the equation, so we eliminate the coefficient of z. So it becomes 1, 1 times z, so z. So we simplify the number on the right hand side of the equation, so we have 12. So that's how multiplicative inverse works in a certain problem in algebra. Closure property is closed for addition and multiplication. It says that the sum or product of any two integers is also an integer. Commutative property is true for both addition and multiplication. The order of which any two integers added or multiplied does not change the sum or product. Associative property works for both addition and multiplication. This property states that when adding or multiplying any three integers, the grouping of the numbers does not affect the sum and the product. Distributive property simply distribute A to the numbers inside the parentheses B and C, then copy its operation sign inside the parentheses whether it is addition or subtraction. Identity property for addition says any number added to 0, the result is the number itself. And for identity property for multiplication says that when 1 multiplied to a number, then the result is the number itself. And for inverse property for addition, it says that when a number or any number added to its opposite, the result is 0. The same way with the multiplicative inverse. Any number multiplied with its reciprocal, the result is 1. In order to verify your understanding about our lesson on properties of the set of integers, I want you to answer this trivia question. Who was the English mathematician widely recognized as the greatest scientist of all time? You can only get the correct answer to my question if you exactly determine the properties involved in the given problem found in A. You can answer this activity within 2 minutes. After you have watched my video lesson, each one of you will answer the following creatively, either through an essay, a poem, a song, an artwork, or through whatever skills one wishes to. You can send your answer via my email or through Messenger. So, thank you. Many thanks to everyone for watching this video presentation. If you have some questions and clarifications, you can reach me through my email and mobile number. Once again, I am Alberto Filcilda saying, never stop learning because life never stops teaching. Goodbye everyone and see you on our next video lesson.